Hello everyone. So in previous video we saw what is Arduino IDE and how to do Arduino programming. So in this video we will see how to interface with sensors. So the Arduino board has wide range of input and output pins that can be used to interface with various sensors. So here are some of the general steps to interface a sensor with Arduino Uno board. So first thing is we need to choose a sensor. So there are many type of sensors available in market. Choose a sensor that suits your project requirements. Second thing is check the specification before being interfacing with sensors. Always check its specification. For example, what? Like at what voltage this sensor operate? What is the maximum data transfer frequency? What is the maximum temperature and humidity this sensor can handle? What is the accuracy of sensor? So we need to check all this data. What is the current consumption? What is the power consumption? And after looking at all this data, we should choose the sensor. Third thing is connect the sensor with Arduino Uno. So connect the sensor to the appropriate Arduino input output pin of Arduino board. Most sensors come with 3 or 4 pins, including power, ground, signal, and sometimes a reference pin. So here, when we are mentioning appropriate pin, so some sensors required analog pins because they give analog output. No need to worry. In this section only, further we will see what is analog signal and what is digital signal. So right now, just keep in mind some sensors give analog output, some give digital output. Some sensors to read the data we need pulse width modulation PWM, and some pins are reserved in Arduino Uno board for some other application like serial communication, etc. So accordingly, we need to select the pin for sensor connections. Fourth thing is write a program. Use Arduino integrated development environment, that is IDE, to write program to read data from sensor. The program should include code to initialize the sensor, read the sensor data, display the data on display, or transmit it to computer. Fifth point is upload the program. So I hope after watching the Arduino programming section you already know how to upload the program. So basically we connect our Arduino board to our computer using the USB cable and we upload the program. Next point is test the sensor. So once the program is uploaded, test the sensor to make sure it is working properly. Use a multimeter or an oscilloscope to measure the voltage, current or other parameters of sensor output. So always when we make circuit or when we make the solutions, we always check it whether it is working properly or not. Okay, so here there are two terms, multimeter and oscilloscope. So we will use multimeter a lot. Why? Multimeter is very handy and it is not very bulky like oscilloscope, and oscilloscopes are more used in the application which require more signal processing. And I will teach you some other tricks and ways to test your circuit. After that, refine your program. If sensor is not working as expected, refine the program to address any issue or error. So now let's see analog and digital signals. So in terms of IoT, analog and digital signals plays an important role in transmission and processing of data. Analog signals are continuous signal. Please remember this word, continuous signals, that vary in amplitude and frequency over time. Many sensors such as temperature sensors, pressure sensors, and light sensors produce analog signal that represent the physical parameter being measured. So you may know, generally in physical environment we always get the analog data, we don't get the digital data. Okay, if you see our sunlight light intensity vary entire day, in similar way our wind flow also vary entire day. In similar way temperature also vary entire day. Morning the temperature could be less, and at noon temperature could be more. Again at night temperature may drop. So entire day the temperature values keep on changing. So generally any physical world data is analog data. So these analog signals need to be converted to the digital signals before they can be processed and transmitted by IoT devices. Why? Because all the IoT devices, all the microcontrollers are, or I should say, all the digital devices are digital in nature. So it means they work on only two states, that is 0 and 1. So digital signals on the other hand are discrete signals that can only take one certain values. They are represented by binary code which consisting of series of zeros and ones. Digital sensors such as motion sensors, proximity sensor produces a digital signals directly which can be processed and transmitted without any need of conversion. In IoT applications, the choice between using analog and digital sensors depends on specific use case and requirements of the application. Analog sensors tend to have higher resolution and accuracy, but they require more complex circuitry for signal conditioning and conversion. Digital sensors are often simpler to use and have lower power consumption, but may not provide the same level of precision as analog sensor. So, let me tell something clearly. Right now, you don't need to worry about converting analog to digital. Arduino already take care of this part. In Arduino, we have analog pins. So, actually, what does mean by analog pins? This pin actually don't send the data directly to the Arduino. So, this pin first send the data to the analog to digital converter. So in Arduino chip only there is one section for analog to digital conversion. So there it first converted into the digital signals and then sent to the main processing unit. So now here is an example of one of the analog signal. So as you can see analog signals vary with time. If you take x axis as a time axis and y axis as an amplitude, then you can see the analog signals vary with time. So at any point if you see, you will get the different value. On the other hand, digital signal only consisting of two states, either low or high. So microcontrollers are digital devices and can't read analog signals directly, hence require analog to digital converter. In Arduino Uno we have built-in analog to digital converter. So in next video we will see how to interface with analog and digital signals and sensors. So that's it for this video. I hope you understood, and I will appreciate if you read about analog to digital converters more. So it won't harm, and it is not a very difficult topic. In case you don't understand, you can put it in lesson comment section or in YouTube comment section. Our TA will help you. Okay, so see you in the next video. Till then, bye.